Hello, welcome to Ekidel. We are a future civil and structural engineer. My name is Justice Nwoka and I am your instructor. Today, I will be showing you how to design a flat slab without any column drop. Now, before we continue, I would like you to see this.
Warning: a structural nightmare could be on the horizon. We hope this will never be your fate, which is why we're here to explore the reasons behind the potential collapse of a flat slab. For those who are unfamiliar, a flat slab is a type of slab that does not have beams and is directly supported by columns. Unfortunately, catastrophic failures can occur if the flat slab is not appropriately reinforced against punching shear. This is where the crucial element of punching shear reinforcement comes into play, which can take the form of a hidden beam tied up by stirrups at a distance of 0.5 to 0.75 of the effective depth. With this kind of reinforcement, the flat slab becomes capable of safely absorbing the design load. So let's not leave anything to chance and take the necessary steps to ensure the safety and stability of our structures. Remember, prevention is always better than cure.
So, on this part 3 of our flat slab design that don't have a column drop, we will now begin with the modeling of our flat slab, okay? Because as you can see from the previous parts, we learned how to do it, how to get our column strip and what middle strip. As you can see, we did the column strip on Y direction and also for LX direction and for every other shapes that are on the other story, which is story 2, as you can see that. So once you're done preparing your column strip like this, it is now time for us to now go and model on the design software. Either you're using any software, Start Pro, another one, but we are using Protastructure for this design of this structure and for this flat slab with a column drop. So with this now, I will now move on to the Protastructure for us to now begin our modeling. But knowing our culture here on Ekidel, that we don't just go to Protastructure to go and now begin to offset grid and all that. That takes longer time and that makes you look as if you don't know what you're doing. So just to be fast, we will have to save one of these drawings as a DSF format. That we are going to export this drawing now to the Protastructure, and before you must do that, you must save 2 layers, column and grid line. Okay, so with that right now, I am going to create 2 layers here, and I'm going to call one of the layers to be column. So I'll call it now column. Okay, and I can choose any one I want here. Let me just leave it as blue as it is okay, and then choose my line weight is okay, 0.4. That's fine. Then I'll also go down and then click on them again and call it what? And call it grid. Okay, that's fine. I can leave it as it is black and everything here is okay, but the main thing is that you are meant to have grid and also a column layer. So by doing this right now, knowing that we have grid lines here already, I am going to assign this grid line, because as you can see, this grid line is having what? Eki center line, which is Ekidel center line. So since we are going to export it to the Protastructure, we are meant to now convert this Eki center line to grid and also convert this this Eki concrete to what? Column. Okay, so let's begin now with the grid line first. So right now I'll just highlight this grid line here and highlight this other one here also. Okay, and then I'll then go now and then do what? And I'll come here and then assign it to what? Grid, and change this to what? By layer. Okay, that's fine. Now basically I would have copied it out first, so let me just copy it out somewhere, not to work on directly on that one. So copy it out, okay, and repeat what I've just done right now by assigning. Click this one here and click every bit of the grid here, come here and assign to grid. That's fine. And again, come for the columns now. Now for the columns now, I'll just click on one of the column here. All right, and this is what? Eki concrete. So I'll come now, highlight everything here, highlight this, highlight this, okay, highlight this here. Okay, let me remove this line here by holding Control or Shift. Yes, that's fine. And then highlight this other one here, highlight this here, highlight this one here, and this final one here. That's fine. And with this now, I'll now right click here and say quick select, okay, to find this what Eki concrete by layer, and look at for what Eki concrete, which is here, and then say okay. That's fine. So you can see that we have now selected all the columns, okay, and all that. So I'll then come now, and then come now, click on this here and assign to what columns, okay. That's fine. Then escape. So you can see that if we click on it now, it have changed to columns, okay. And basically it's meant to be by layer here too, okay. So I'll just quickly right click now and then says what select similar, okay. That's all that is selected. Yes, that's fine. Then come here and choose to what by layer, and choose this one to what by layer, okay. So they must be by layer and all that. So with this now, we can now export it to the software Protastructure, and by exporting, we are meant to save just this drawing on a single DSF drawing environment, okay. So with that now, I will have to do what? I will have to highlight this drawing here and type W, enter, and I'll click on this dot sign, this symbol here, and I'll click on this now and locate where I'm meant to save it. Let me just go to the place where we have our folder for this flat slab, Ekidel YouTube design building. Yeah, that's fine. So sorry, Ekidel course videos. That's fine. So here now we are going to put it here. So I'm going to put it right now and say first of all change to DSF. You will see that we already have a DSF here before. So I'll just come now and say flat slab without column drop, design, okay, design. That's fine. So I'll come now and then click on what save here, okay, and then click on what okay. That's fine. So on this okay now, the next, once I've done that now, the next thing we'll do now is to go and open up the software in AutoCAD. Open up that DSF file again. Let me just go here and then click on what open here, open. So if I click on open right now, I'll change here to what DSF, and then come and locate where I save the file, because we are meant to save that drawing. Yeah, open this one right now. Now on opening this drawing now, you can see what we have here. We have this drawing here. I'll just turn on my line weight, and then you have this. So we are meant to put this drawing at origin, okay, because it is not at origin currently. So to put a drawing at origin, you just type L, enter, okay, and then you then go over now and then type 0,0 and press enter, okay, and then click on anywhere here. So by clicking on this now, you can see that this end here, this end of the of this line is where we have our origin. So I'll just escape and try to locate the end of that line. You can see where our origin is here. So we are gonna copy this drawing now. We copy this drawing or move it. Don't copy, just move from a reference point here. Let me just pick this column point here, reference point, to that end of that column. Not the beginning, but the end. The end here is where the origin is, okay. So I'll move it now to that place. By moving it now, you see that our coordinates will have to come here. So I'll come now and then keep this here, okay, and then click on this now and then enter, okay. So with this now, we have placed this drawing at origin, okay. So make sure you don't move it again, because once you move it, it will go from origin, okay. So with this now, we can now go ahead and go and do what? Go and now save this again. Control or just save, or press Ctrl X to save again. Say yes, still save at DSF, and say yes. They will ask to replace it. Say yes, replace it, okay. Then you now go and do what? Then close. Say no, don't change to DWG. So just say no, okay, that's fine. So with that now, you can now see what we have done so far. We have now saved that. The next thing now I'll do is to gonna open our Protastructure software, okay. So on opening this software right now, the first thing you do is to create a different new project. Okay, so since I already have this flat slab being modeled here, I'll just go and create a new project. Okay, so you create a new project and type in the file name. Let's say right now the file name we are designing for is what? Flat slab. Maybe basically is good to use the client's name. So this is let's say Mr. John, right? Mr. John flat slab design, Mr. John's flat slab design. Okay, you can just say without drop. So the whole essence is that you are meant to put in the file name to how you understand it later. Okay, that's fine. So once you're done that right now come and choose what your design code. I am currently using Protastructure 2022 for this design, but regardless of the the changes compared to other versions that are low, you will still be able to grab up everything. So right now I'll then go over here and then pick I like to use the current code, which is called Eurocode. Okay, so I'll come now and pick what Eurocode here for my design as our design code, and then I'll come here and then do what? Click on what? OK here. Okay, that's fine. So on doing this, on click on OK now, you will wait for it to load up the design, the software interface for this Mr. John flat slab design without drop. Okay, so let us hold on now for it to load up. That's fine. So as you can see right now, the software environment is now loaded for Mr. John flat slab design without drop. Okay, so with this now, we will now need to import the DSL file into this software. Okay, so to import that, you have to go to building setout. Okay, and then click on this place that says external reference drawing. Okay, and then you will now have to do click on this add DSF. You can see here add DSF, and then we'll now have to take us to our computer, and then we'll just go and locate where that file was saved. It was saved on that document, and inside document it was saved inside YouTube Ekidel course videos, and inside flat slab, and we have this here. That's fine. So I come now and then click on this here, and then you allow it to load up here. Now once it loads up here, the first thing you do is to do check this up here, make this active. Okay, and then once you make that active, hold on for it to check, because if you don't make it active here, it will not show on this background as if like a trace. Okay, and which you will need a lot. Okay, so right now it's showing right now. You can see that right now. You can see right now it is showing here. If I go and turn this off, it will go off. So always turn it on, and then click on this place here, use color. You can see that it's now using the color that we have on our CAD file. And also check this other one here. That's fine. Now once you have done this now, the next thing you do now is to do import here. Okay, you have to now import those column grid and those grid lines. Sorry, the column layer and the grid line layer. Okay, so I'll come now and then click on here, import. That's fine. So I'll wait for it not to now display the next interface, which will just come up just now. Okay, so on coming up now, you can see that it has already ticked our grid lines and our columns. So all the members or all the properties with these grid lines, with this layer property, will come up here. If it's for grid, it will come up here as axis, and for column as our column member. Okay, so with this now, don't set anything again. Don't click on this place that says move to origin, because we have already set our drawing at origin. Okay, now I'll do now, click on the place that says import. Okay, then click on this import. Now we will then have to do wait for it to import these layers for column as column member. Okay, and then grid lines as grid. You can see that number of lines converted is 14, which is to grid lines, and polyline for column is 42 columns. Okay, that's what we have. Let's now hold on for it to finish up. Once it is done, you will see that it will show, and here this close button here will be active. Okay, so right now it is trying to finish up the conversion. So let's just hold on for that to complete. Yeah, so let us hold on. I think it's almost done. Yeah, so we can see that it is done. Once you see this print log, that means that it is done. And once you see this close being shown, once you hover your mouse button on it, then it is done. You can now choose to do what? You can now choose to close the interface, and then say OK. So always say OK, then say OK. Don't say cancel. Now you can now see that we now have our grid lines. You can see that. And also our columns. Okay, so the first thing I'll do right now is to rename my grid lines. As you can see that we have a trace one from our CAD file was showing 1, 2, 3, 4 and all that. So we have to now rename this grid line that came automatic from the software to as what we have here. So let us look at now. You can see that. Let's begin with this one now. Let's begin with here. So we have to rename this one right now. To double click on this grid line right now, on this A1, and then rename to what? A. Okay, just hold on for that to open up, and then come here and put what? A, because that's what we have here as A, and then say what? Update it to change to A. Okay, that's fine. And then as close, come again here, double click on this one, A2, and then change to what? B, because that's what we have to do, B, and then say what? Update it to change to B. That's fine. And then come again right now, change this to what? C. Double click on it and change to what? C, and all that, all updates. So continuously do the same thing and all that. Do the same one here also. Change this to what? D, and then come here. Basically, most people don't like to change, but me, I like to change so that I can have my bin drawings or my at least my grid lines aligned. Okay, if someone seeing your drawings having A1, A2, it doesn't really make sense, because the one of the most standard one is to have what? Is to have 1 to 3 for the vertical, and then ABCD for the what? Horizontal grids. Okay, so that's fine. So I'll just change this now to what? F. Okay, so once I'm done with the horizontal one now, I will now move on to the vertical ones. Okay, vertical ones right now here says to be what? To be 1. So I'll double click on this right now and then change this to what? 1. Okay, and then say update. So you have to do it now for all of them here. Do it again here. Change it to what? To 2. Okay, and then update. That's fine. And then come again right now, double click on this grid line, change to what? 3. So always have the culture of changing your grid lines to as what is stipulated on the arcade drawing, so that they can be able to read it freely without any kind of confusion. Because if your structural drawing have different grid line naming with the building drawing, you will see that they'll find it difficult to read your drawings and to understand it, and they might end up, even at site during the construction, they will use a pencil or a pen to now correct those grid lines so that they can be able to read it fluently and easily. Okay, that's fine. So always have the culture on doing that, because a good drawing, a good design should be able to be easily interpreted. Okay, that's fine. So right now, this now have to this will change to what? 6A, because we have 6 here, so this will change to 6A or 6A. Basically on the CAD file it was not named because it is just on this side, so I can choose to name it to what? 6A. Yeah, 6A. Yeah, and then updates. Okay, that's fine. It will change to 6A. That's okay. Then this is now what? Grid line 7. Okay, this now becomes what? Grid line 7. Okay, and I'll do what? Update here. Okay, now the reason why I have to rename them is that because at the end of everything we are going to remove this trace. Okay, by coming here right now and then uncheck this. If we uncheck this now, you will see that it will go off. Can you see that it has gone off? Okay, so make sure. But for now we are still modeling. I'll leave it as on and then just say okay. That's fine. So with this now, I will now you can see that we have changed all our grid lines, as you can see. So let's now begin to look at our columns and see if there is any double column anywhere, but I doubt, because during our GA we didn't paste any of the column twice on any place. So you can see that all our columns are appearing how they are meant to appear, as you can see them right now. So once you're done doing this now, the next thing we'll now move on to is to now move into the modeling. Okay, which is the modeling of the slab. Okay, now to model the slab now, you now have to do what? Come to modeling tab here. Okay, and then click on your slab. Don't forget that we are designing for what? For flat slab without column drop. Okay, now as you can see now on the dimensions that we have here to be what, 6 meters, and we have here to be what, 5 meters. So each of these panels is what, here is 6 by 5, here is 2.5 by 6, here is 6 by 5, and 6 by 5. So you can see that the major panels that we have here is 6 by 5. So with that now, because this will come into play when you're calculating your depth of slab to use, okay? But basically, flat slab starts from 250 to what, 350 and all that, and what above, okay? So right now I'll have to click on this place here, slab here, and then they will ask you to what, define the load first. You say yes, it's just say come here and say what, yes, define load first, and then come here and then click on what, loading generator. This is just a 2-story building, so we will not consider wind load. I should have clicked here and consider wind load, and based on that, this building is in Africa, so there is no much temperature issue compared to all this snow load and all that, so we will not consider temperature issue on that. And then we'll just go right now and then click on what, okay, and all that. We are using Eurocode, don't forget, for our design and all that. So you see that all our code now will not be listed down here, okay, but there is no window because this building is less than 10 meters high, and because of that we will not apply wind load, okay? And then come here and then say okay. You only apply wind load for when your building is what, more than 10 meters high, okay? So right now on this now, we will now have to do what, notify impute our what, our slab depth. So I would have to put what, 250. Now how did I get this 250 here as our slab depth? What I just did is to do what, let me just show you what I did right now. Open back to our what, calculator right now. From this our CAD file right now, you can see that we have here to be what, 6 meter and what, 5 meters, okay? So if we go on now by saying QC means calculator, and then open up now, and then type what, 6,000 divided by what, 26, which is the what, effective span depth ratio. And I'll do what here, click on this. Now you can see that we are having what, 230, okay, 230 as our minimum depth of slab, okay? And if we also have to use this other one here, 5,000 divided by what, 26, we still have what, 190 something, which is approximately around 200 and all that. And if we still want to use the average, which is of this span, whichever is less, we will have the average to be what, 5.5 divided by what, 26 and all that. So we're having 2,100 and something as a depth. So with that now we have 230, 21, and so that's why I want to use what, 250, which is higher than every other one. Most people in Lebanese, like I do a design for Lebanese company, they like to use, even if they get 180 as a depth of slab, which is very, very small, you can't get that, they like to use 30 cm, which is what, 300 millimeter thick for their minimum depth of slab, okay? Yes, that's because the depth of slab used to control punching failure a lot, okay? So they like to use 300 millimeter and all that for the depth of slab, but I'll just show you how to calculate your depth of slab, okay? But our advice, based on experience, don't always use your depth of slab for flat slab without column to be lower than 250. Most people take 300, okay, as their minimum. So our advice, you play around that area, but always make sure you check your calculation first, because at the beginning we'll have it to be what, let me say 8 meters right now. You can see that at 8 meters right now, let's say 8 by 7, you can see that at 8 meters and all that, you can be seeing that you're by 26, that will be around 3 something. So always check to confirm that. Once you confirm that, they'll always add like 50 on what you have done with your calculation. Add like, so in this case right now, if here was 8 meter by this, I would have tends to use around 350 or 375 as my depth of slab, okay? That's fine. So by knowing that right now, let's now dive in back to our what, our software here. Okay, so on this now, that's why I'm using what, 250 as my depth of slab, okay? So on this now, 250, and then leave this as it is, 25, cover of concrete is okay. Then come here just now, and then for the loading right now, this is basically an office complex, okay? So since it's an office complex, I'll just come here. For the dead load, I'll put here 1.65. Now this dead load I have told you guys before, if you have not watched my other videos. Now this dead load is comprises of what? Finishing load and what? Partition load. So in this case right now, I am taking my what? Finishing load to be what? 1.0 and my partition to be what? 0.65. So if you add them up together, that will give you what? 1.65. So that's how I got this 1.65. okay, is the combination of what? Finishing load and what? Partition load. That will give you what? The dead load. Okay, now on this last side right now, this is the what? Imposed load. Okay, this imposed load right now simply means the what that structure is to be used. Like I said, this is an office complex, so I'll come here, right click here, and I will see a series of load here, as you can see that right now. So I'll quickly look out for the one that says office. You can see that office above ground. Okay, yeah, this is office above ground. We are not designing office below ground. This is for underground. So this is office above ground. So I'll come here right now and then click on this 2.5 under that. So by doing that right now, I will now come to do, I begin to insert my slab. But knowing that this is a flat slab, so we will have to come here, general, and change our slab insertion to what? To only axis region. Okay, it was normally default at beam region, as you can see now right now. So we'll come here and change to what? Axis what? Region. Okay, and then we'll now begin to do what? Click our slab here. Okay, we need to click now. We'll click on this place now to insert what? Our first slab here. Okay, now you can see that we also have a slab around this place because the slab is meant to flush with the column what? Region. Okay, so click on this one here also to put our slab there. Now you can see that it is saying that it is too small to put our slab here. Okay, you can see that they said slab insertion axis cannot be found and all that. Okay, that because we have not yet provided what? Our axis here. Okay, so let me just insert one more slab here before we can now provide the axis around that area. So I'll have to do what? Close here and then provide axis on this line. So by doing that right now, I'll just come here, click on this, right click on this grid line, offset it, and then come here and place directly at the edge of the column here, which is at 150. Okay, also from here right now, click on this other one now, click on this one, right click here, and then offset to this face here at 152.25 also. That's fine. Then right now we have to now do what? Convert this axis, this one right now, to do what? To a ghost axis. Okay, so come here, remove these bobs, and then make it to be what? Hidden axis. This is actually called a ghost axis. Okay, so I'll come here right now and then click on what? Update. That's fine. So you can now see that our list now is now showing what? At hidden. I can see that. Come here again, convert this other one also to what? To ghost axis. So remove this and make it to hidden and then update. Okay, that's fine. So right now I'll just copy this right now. I'll then click on this one now, right click here and do what? Offset, and offset it down to this other side here, and then keep this here. That's fine. And again I will click on this vertical one here, offset it right now to this other face here, and then keep this here. Okay, you can see that we now have this face now, this area to be having a grid line. So I can go right now, click on this slab here, right click here, and then properties, and then come now and then insert here. So we will now have our slab now being inserted inside here. Okay, that's fine. Also the same thing will happen here. Also click on this, it will have a slab inside here. Okay, and then click on this and then click on this. Okay, so basically, but most times I don't like to insert this like this because this slab here is too small, as you can see that. And if you look at this place here, you can see that there is this slab only ends directly here. That means that this place here around this small region here doesn't have a slab. So what I do is that I like to do my slab like this for flat slab. I just showed you one example to do that. So this is what I used to do. Although when you do this during your building model check, it will show you that the slab is what? Overlapping, but just ignore that warning. Okay, because that's the best thing. That's how it will appear at site and not this way which we're having our slab. So basically I like to design what they will do at site. Okay, that's what I like to design during the construction. That's what they will do. So I like to implement what they will do during the construction also during in my design. Okay, so right now just click on this right now, right click here, properties, and then look at what I'll do right now. I'll come and change this my slab insertion right now to what? To pick point. Okay, So I'll begin to pick this point here, okay, and I'll come here and pick this point here, okay, and I'll come here and pick this point here, okay, and then I'll come here and pick this point here, okay. So you see that we now have our slab now. So basically, let me just remove these other ones here, this one here. So this is how our slab will be. You can see that it is now doing what? It is now overlapping through the column, but this is how it will be. It will the slab will have to pass through the column, and even on this side also, okay, because if you can put just one small slab inside here, the software tell you that there is a small slab area which is inside here and it's not really good. So I'll allow that overlapping warning during my design, okay, because that's how it will be. So right now with that, now I'll take off these other ones here, too, and then use the same principle right now by pick point and then insert on my slab now, okay. So I'll move this now, then come here, click on this, okay, and click on this, okay, and then click on this, that's fine, and then click on this one here, and we will have our slab there. Again, remove this, come again here, click on this again, click on this here again, then click on this one here, okay, and then click on this here, that's fine, and then again come again here, click on this, that's fine, click on this, that's fine, and then click on this here, and then the final one here, that's fine, and again I cancel here, come again here, click on this here, okay, and then click on this here, the edge here, and click on the edge here, okay, and then click on this other one here, that's fine. Again I cancel, and then I can come here, click on this edge here, okay, and click on this edge here, that's okay, and click here and then click here. So repeating the same principle right now. Basically, I don't like pausing my videos. I would like you guys to see how everything will like flow. So I don't like pausing my videos. Else I would have paused this video and then say that you guys should repeat the same thing for all other panels, okay. But let's just watch how it will appear, because I like you to see how it will appear and how everything will appear, okay. Most people on their course videos, they used to pause their videos, okay, and then complete what you are seeing. But let me just complete it with you. Click here, and then click here and then click here, okay. I know why I am just clicking these points, okay. I'll do again here, click here, okay, and then click here, okay, and then click this other point here, okay, and then click here. If you are using lower version, you're meant to be clicking this place here, okay. You are meant to be clicking here, but since you're using a higher version, can continue, it will just know that what you're doing, you are meant to put a new slab, else you are meant to be clicking this one, this point here, okay. I'll click here, okay, and I'll click here also again here, okay, and then I'll click this other point here, okay. You can see that it's not working, so you must have to click this point here to cancel, okay. Then continue again, now click here and then click here, okay, and then click here and then click here. Yes, yeah, you need to be clicking this cancel, yeah, because most times it will not work, okay. So again, click here, okay, then click here and then come on now and click here, okay. You can see where I'm clicking at the edge and not the center, okay, so that the slab can cover the column, okay. And then cancel here again, and then come again now, click here, okay, and then click here, and then I come here, click here, and then I click here, and that's fine. And I will click on what cancel here, and then I come again now, I click here, and then click this one here, okay, and then click, and then click. You can click on any direction, either anti-clockwise or clockwise, as long as you are following the same sequential method, clicking. And then if you're going anti-clockwise, you have to go sorry, not that one, you have to cancel again, cancel, and click here, and then come here, click here. So you have to be careful when you're doing that, okay. Sorry, you can see that we have, so cancel again, then click here, okay, and not this place here but here, click here, okay, that's fine, and then click here, okay, and then click here, that's okay, that's fine. So again right now, click here and then click here, Okay, and then click here. Okay, and then click here, and then click here. Okay, that's fine. And then come here, click this other one here, and then click this other one here. Now flat slab is very, very stressful when you're designing, so that's why you have to charge high for a client that needs what, a flat slab. You charge the person high. Okay, so you click here, let me go this way now, click here, and then click here. Okay, and then click here. Finally it will say insert. Okay, that's fine. So right now you can see that we are done inserting these other places. Now this other one, now I'll have to do what, change to what, let me cancel first, then change to what, axis region, and then because this one's abandoned with what, axis. Okay, so I'll click now and then make it to be faster. Click, 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 click. That's fine. Okay, let's go on. Let's hold on now for it to implement everything we have clicked and all that. Okay, so you can see how I have walked you through on how to insert your slab perfectly on when you're doing for what, flat slab. So this is how to insert it perfectly. Okay, that's fine. And I'll come now, do what now, and then close here. Now if you look at this place, now we have a lift wall around this place here, don't forget that. So with this now, I will now have to do what, come here and click on my modeling here, and then click on what, wall here. Okay, now on that wall now, our lift wall is what, 250. Yes, 250. Let's confirm that. So we will now measure our lift wall now to see. Let's see that from here to here is what, yes, you can see that it's 250. It is 250 as our lift wall. So let's go and model that lift wall there as 250. And on this place we have what, we have a door and an entrance to the, like an opening, and also an opening to the lift. So right now let's now go to that model it on that place. Okay, that's fine. So right now you can now see, let's now begin to now click on what, this place here. So it will now appear the wall is 250 and all that. Yes, that's fine. And then with that, let's now begin now click on this one here and click on this other one here. That's fine. We have our first wall, and then click on this, and then click all the way down here, our second wall. Okay, and then click on this, and then click on this one here, our third wall, and then click on this here, and then click on this here. We have that, and then click on this here, and then click on this here. The next thing now, that's fine, and then click on this other last one here, and then click here. Okay, that's fine. So right now there's an opening of door here. All right, and that door opening, let us measure it here. We can see them here. Measure it right now. Right click now and then click on what, go down, you see measure. Make sure you don't selected. Okay, right click now and then you see measure. Then click on this and then click on this here. So the door opening is what, basically around 1.5. okay, you can see that 1.5, that's the door opening, 1.5 millimeter. So right now I'll click on this this wall right now, right click and then say what, wall opening editor. I'll click on that. Okay, allow the interface to open up and all that. So on this now, you can see that we have our opening of what, 1.5, and the height of door is basically 2.1. so right now I will then click on what here, add. Okay, so this is how to add wall opening. Okay, opening on a concrete wall. Okay, so right now I'll have to do what here, the height right now, this place here, this basically first, this one here, this is 99.2. So this is basically what, 1500. That's our width. Okay, no, not this one, sorry. This other one here, this is the, that's 1500. Yes, this is the one. So here and right now is the distance between the face. So let's confirm from what we have right now on our CAD file, the distance from here to here, what we have. Okay, so let us go and confirm that right now. So from our CAD file here right now, let's look at that now. From dimension, from this point here of the wall to here, what do we have? 1375. Okay, 1375. So let us then also the same thing here, I believe so, from here to here, 1375. Okay, that's fine. So right now, back to this place now, we have to put here 1375. Okay, I don't know if, let's confirm if it's 57 or 75. Let's take again from here. Okay, from dimension from here to here. What do you have? Yes, 7.5. That's fine. Sorry for my forgetfulness. So right now I'll click on that. Now it will change to this. That's fine. And again, this now, the height now here that says Y here first be 150. Sorry, not that one. This is 100. Then here should be what? Well, 150, which is basically just one step into the building. Okay, that's fine. So with this now, I'll have to do what again? You can see that go back here is too close to the building. They're saying that it is too close here. So right now we have to make here increase here up to, because basically let me see from our CAD file again. Sorry, from our CAD file again. This one here, measure here from here to here is what? 250. So right now QC 1375, which we got from this other end here, minus what? 250. What do we have? So 1125. So at least let us go and put that to be able to have this 250 here. So right now, back to this place now, we will put here 1125. Okay, that's fine. Okay, that's okay now. So then come now and then click on what? Okay here. Then you see that our opening has already appeared. If we check on our 3D view right now, let's see the 3D view and see where the opening is appearing. 3D view interface. Okay, and then once it comes up now, you can see our opening there. Can you see that? Perfect. You can see our opening there. You can see our opening there perfectly. Okay, that's fine. So let us go back to our plan view again right now and do the same thing for this other one right now. Right click now and then to a door opening here, and then add. On this adding now, we will now have to do what? Here now, we have already known that this W here is what? 1500. Okay, and then DH here is what? 100, which is the door height. Here becomes what? 150. Okay, now this X now will now be what? 250. Let's see that. Yes, that you can come to this other side. That's fine because it's coming for this other side. So then come here and then do what? Okay it now. Then let's see the 3D view how it appears. Yes, correct. This is how it is. Okay, so you can now see what we have just gotten right now. Okay, so this is now what our openings for the door. Okay, and you can also see how our flat slab is now showing perfectly here. So by doing this now, we have successfully done for the first story and all that. So if you can look at the CAD file again here, you can see that from the CAD file here, we have what? We have this. We have up to 2 story. As you can see right now, 2 story. So right now, let us now go and do what? Insert this other story here. Okay, so we have successfully done for this story. Okay, this story. Let's now go and insert for this other story here. But before we do that, we will now begin to do what? Cut our slab strip, because we are meant to insert each of these column strip and middle strip on the software, which I'll show you just now. So back to our CAD file now, then back to, you can see what I've done right now. So back to our plan view right now. You can now see what we have successfully gotten here. So on the next part, which is the part 4, I'll be showing you how to now do what? How to now place your column strip and middle strip on this software. Okay, so and that will be on the part 4 of this video. Okay, and all that. So right now, let's now go and turn off this trace line that came. So go back here and then click there and then come here and turn this off. So this will always be there for you anytime you want to turn it on and all that. So I'll come here and then say what? Okay, so we'll have our plan now being cleaned up. Okay, that's fine. So you can now see how to basically model what? Model a flat slab. But currently this is just like a 10% of what we have done, what we're meant to do for a flat slab, because we have not yet done the flat slab. This is just slab we have done. The main flat slab is when you begin to provide the column strip and the middle strip, on which we did on what? AutoCAD. Okay, you have to implement that here. Okay, that's fine. So that will be on the part 4 of this course video. Okay, that's fine. So watch out for the part 4 of this course video. See you again by this time next week. Bye for now. So you can see that this is apparently a complete course on what flat slab. So for you watching this video as a free video on our channel here, I would say that you might not be able to get everything free on this flat slab. So I would advise you join the premium of our Ekidel, because we have already added the premium video there on our premium videos. We have added the complete course video on our premium. You can join our premium, but if you don't want to join our premium, then you can purchase the complete design for this flat slab following the link down below and all that. Okay, so thank you so much and God bless you. And before you go, I will advise you subscribe to our channel Ekidel, and also recommend your friends to also join our channel. Okay, so thank you so much and God bless you. We love you and see you again by this time next week. Bye for now.